Hey guys, welcome back to my channel. Good evening. Um, Yesterday we were finishing off the heap section with the common implementation of heaps using max heap or minimum heap to find the kth most common element. Today we're gonna go for the greedy algorithms. So what is a greedy algorithm? I'll just quickly share my screen. Yeah. So greedy algorithm is basically any algorithm that makes the locally optimal choices. So it's not a data structure. Um, it's not a single algorithm also. It's just any algorithms that fits its definition. So first of all, what makes a decision optimal? So we just said that. So these are the chapters that we have gone through, and these were all the data structures. Today is a bit different one, greedy algorithms. And its functions include being local and also making a decision optimal. So making a decision local means that when it considers only the available options within its current step. So it's only based on I'll just quickly, it's only based on the information that it has at the time. Just 1 second. Yeah, or maybe it's better if I just use my integrated camera. Yeah, much better. So it's only based on the information um, that we have at a time, and it doesn't really consider any consequences that will happen in the future from this decision. So that's what it means by making a decision local. And making a decision optimal means that just optimal decision. So um, it's selecting the best possible decision that will make the best possible outcome at that stage. So, for instance, selecting the bigger number in between two, then obviously the optimal number is the bigger number. So, being optimal, making an optimal decision, and making a local decision is part of greedy algorithm. So, um, what I learned is that most greedy problems will ask you to either find the maximum or minimum, uh, but it's not always the case. And like we explored in the previous chapter in the heaps, a lot of the greedy algorithms will be employing this heaps as well. So yeah, that's like the basic definition of being greedy. Um, what are the steps of implementing a greedy algorithm? So first of all, we define a problem. So we define a problem, we state the objective that needs to be optimized. Second, we identify um, the choice at every level. So we determine the locally optimal choice at each step based on its state, by the best local choice at each step. Third, we make the greedy choice. So we select the greedy choice and update the current state. And then we iterate it. So we repeat it um, over the length of the problem. So that was also an implementation. Usually greedy problems are those medium level difficulty problems that actually isn't that hard because we're not using complex algorithms. We're not trying to implement a complex data structure. It's mostly just sometimes sorting, sometimes using a heap, but that's about it. But the difficult part is rather than implementing it, justifying the choice of using greedy algorithms. Because the thing is, the greedy algorithms is going to reduce the complexity by miles, by miles. But the thing is that sometimes it will not make the absolutely correct choice, correct outcome. So for problems like in leetcode, where we require the code to create, the code to pull out the absolutely correct solution, it cannot be that great of a solution. But in real life situations where we can sacrifice a bit of accuracy um, for a whole load of complexity off. So in those kind of situations, greedy algorithms are really, really useful. That's what I've told. One example of greedy algorithms used, there are lots of different cases where greedy algorithms are used. Dijkstra's algorithm also employs greedy algorithm. Um, knapsack problem. Those are very famous algorithms and problems. Uh, I'm pretty sure you guys have also heard about this problem called trade traveling salesman problem. So if you study computer science or related study, this type of problem is used to teach you the algorithmic complexity like NP hard, NP complete. This one is an NP hard problem. So what is an NP hard? It's where it can be solved in non-deterministic polynomial time. We're not going to go deep into this, but yeah, just know that it's an NP hard problem. But the thing with this problem is that so given a list of cities and distances between each pair of cities, what is the shortest possible route that visit each city exactly once and return to the original city? So while we have to find the shortest possible route, we have to visit every each cities, right? And to go over all these cities, the most correct proposed solution has a time complexity of 2 to the n square. So this. But if you use the greedy algorithm, so for instance, heap, it will reduce the time complexity by miles, and this this will bring down the time complexity to n square. So yeah, there's a really big difference. Although it's not gonna give the correct solution, the absolutely correct solution. So from accuracy will deviate by 10 to 20%. But still it's a big improvement in time complexity. So many it is one of the highlighted ones out of the solution. So that's why greedy algorithms are explored commonly. And since in LeetCode style questions, it is important to determine if whether to use greedy algorithms or not. And like I said, it's not a data structure. It's just one of the methods, one of the algorithms, not one of the algorithms. It's just all the algorithms that uses this kind of approach to the problem. What did I say? Optimal and making a decision local. So yeah, like just finding the shortest possible route. We're just deciding at the local level. So let's say that you're delivering some some food. You're only deciding between the shortest distance to you, the two houses that shortest that's the nearest to you, and then move on to the nearest to you, and then so on and so forth. Okay, anyways, I think that's enough for explaining the theory behind greedy algorithms. Oh, finally, also one more thing. The disadvantage of using a greedy algorithm is that order in which elements are considered can significantly impact the outcome, and it focuses on local optimizations and may miss better solutions that might be required in a broader context. And it also may not find the best possible solution. So it cannot be perfect. That's all. Anyways, let's look at this medium level difficulty problem 2126, destroying asteroids. So given an integer mass, which represents the original mass of the planet, you're given an integer array asteroids, where asteroids I is the mass of the ith asteroid. And when the planet collides with the asteroid in any order, if the mass of the planet is greater than the mass of the asteroid, then asteroid will eat up this asteroid. The planet will eat up this asteroid. And then if it's the other way around, then yeah, the planet is destroyed. But our aim is to destroy all the asteroids. So in all the cases, planets should be bigger than greater or equal than the mass of the asteroid, right? So it's almost like I'm pretty sure everyone has played that game of fish frenzy, where you start with a small fish and then you eat up smaller fishes than you. Then it grows, and you keep on growing that fish. Yeah, I think it's also one of the famous um, advertisements, game advertisements that you see on YouTube. I don't know, maybe it's just me. But anyways, you can see from the test case, when mass is 10, asteroid is 3, 9, 19, 5, 21. So beats of 3, 13. So the next best optimal when you're using greedy algorithms, the next best optimal is 5. So we eat up 5, then it becomes 18, and then we eat up 9, 27, and then we eat up 19, 41, so on and so forth. So what will be the way to implement the greedy algorithms here? So we said that we have to identify the best local choice at each step. So what will be the best local choice at each step? It should be that we encounter the smallest possible asteroid first, right? Because that will be the best step at each stage, eating up something that's smaller or same mass as you. So in order to do that, and we're given an array, I would say we use a sort. So quick sort. We're going to use sort. And we have to update the current state, right? So we can do that by adding it to the mass, of course. That's simple. And then we repeat it over the length of the problem. That we can do by just iterating through the sorted list. If the current mass is less than the asteroid's mass, if the current mass is less than asteroid's mass, return false. If current mass is sufficient, we add the asteroid's mass and move on. So, and return true if all asteroids are destroyed. Okay, let's try to solve it then. I think this one is really, really simple, although it's given a medium difficulty. So like I said, we just sort it. We sort it in an ascending order. so that we encounter the smallest asteroids first, and that's the best optimal solution at any given stage, and that will be using greedy algorithms. That could be considered using greedy algorithms, and we iterate through each asteroid. So for asteroid and asteroids, and we check if the current mass is sufficient to destroy the asteroid. So if asteroid is bigger than mass, then return false, because the planet will be broken, destroyed. And if not, we add the mass of the asteroid to the planet's mass. Yeah. And then after this iteration is done, we return true. So let's see if this works. Yeah, that was really simple, right? So these kind of simple problems, in this case, we use sort. So sort here, quick sort is considered using greedy algorithms. Although we have used this, we can tell the interviewers in the interview that we have used greedy algorithms. And in this case, because we are iterating through the length of an array, that will be n times the complexity of the sorting mechanism, that's log n. So time complexity will be n log n. So let's submit it. And we can see that, yeah, n log n time complexity. And we beat 57%, so we are like halfway there. Anyways, that was it, guys. It was a quick introduction to greedy algorithms and how it works. One of the instances where it works. We're gonna explore more questions tomorrow. I think maybe it's best to solve 2 questions tomorrow, so that we can wrap up this section and then move on to the binary tree. Yeah, I really liked this kind of easy algorithms, and hopefully tomorrow's one is easy, or if not hard enough to train me for the interviews. Anyways, thank you guys all for listening, and I'll see you guys tomorrow.